Back guys, in this video we'll be performing the TCP. So firstly open the TCP and to give you a brief idea about what the protocol TCP is. TCP is a transmission control protocol and it is a unique protocol. It varies from different protocols uh, it is a protocol that sends the data from a source to the destination in a reliable way. It does ensure that the data would be sent no matter what, the data would be sent to the destination at any cost. So let's just start performing these exercises. Firstly, capturing a bulk TCP transfer from your computer to a remote server. So yeah, start up. Go to this text file. So the text file is like this, guys. So it's big text, and store this file somewhere on your computer. So I have. You can just save it like this. Save as I have saved it previously. So you just save it. Now go to this HTML file. If you come to the just copy that and paste it over here, and if you just come, it will be like this, and you just have to choose a text file over here. I'll just choose a text file and don't just upload it. So for uploading it, just restart it and now upload it. Once you have uploaded, it shows like congratulations, you have uploaded. You have to stop the packet capture and analyze it. I'll just stop it and filter it with TCP, and these are the packets that you have got for this. And now what you can do is that first look at the captured trace. So for that, what you have to do is in the previous videos we have installed the Wireshark traces zip file, right? So the thing is, once you have completed this, you have captured the TCP packets. So what you have to do is just open the file of TCP ethereal trace, and once you have got these packets, you'll just answer the question. We'll just start answering the question. So firstly, what's the IP address and the TCP port number used by the client computer that is transferring the file to the website? So for that, the thing is, the source IP address is 192.168.1.102, and the TCP port number is 1161. Okay. So you might have a doubt like what is SYN, what is SYNAC, and what is ACA. So before that, there is a term called three-way handshake. So it generally contains like wait a minute. Wait a minute, guys. So it's like a three-way handshake, three-way handshake. So firstly, it consists of SYN pack and SYN ACK and ACK. So generally SYN is called as synchronize, and SYNAC is called synchronize acknowledgement, and ACK is just called acknowledge meant. So next, the thing is like wait a minute. There's a drawing thing. Okay. It's just like for example, if there is a source path like called as A and a destination path as B, the A port is there, right? So it sends a message from A to B for establishing a connection, and that's called a SYN-pack. It sends a it says like I want to establish a connection with you, and B is like yeah, the connection is being established towards A back again, and A sends B again. Whatever the message that it wants to send would be transferred in the acknowledge back. So these are done in three ways, right? So the first one is in SYN, and the second is SYN-ACK, and the third one is ACK. So here the A is known as a SYN and B is known as a ACK. And the questions are like what's the IP address and these things. We have answered the like the IP address is the 192.168.1.102 and the TCP port number is 1161. So the second question is what's the IP address of the specific website and on what port number it's sending and receiving the TCP segments for connection. So for that, see over here the destination computer IP address is to receive the file. The destination IP address is 192.119.245.12. It's a destination port, and the port number is and the destination port number is 80. Okay, you can see the destination port number is 80. So next question, and everything just based on this complete thing, so don't worry guys. So fourth question is like what's the sequence number of the TCP SYN segment that's used to initialize a TCP connection between the client's computer and the website, and what is it the segment that identifies a segment as SYN segment. So before that, you need to know about some terms like a sequence number. So a sequence number is a unique identifier for ordering and managing the data packets in network communication, especially in the TCP. And TCP segment and TCP segment is known as a important data unit measurement for the segments. So this question is like what's the sequence number of the TCP SYN packet. So the first thing, we'll just open the Wireshark, and the over here the sequence number is 0, right? Okay, the sequence number is 0, and what is a segment that identifies a segment as a SYN segment? The SYN flag is set to over here the SYN flag is set to 1, right? So it indicates that this segment is a SYN segment. Okay, so moving forward to next question, what is the sequence number of SYN-ACK segments sent by the website to the client computer in reply to the SYN, and what's the value of acknowledgement field in the SYN-ACK segment, and how did the website determine that value? So here the website okay, here the sequence number is 0, by the way. In the previous question also same, right? The value of acknowledgement field in this is acknowledgement field is not set over here. So for that, wait, synac, right? Okay. So we have to go on to this thing, and over here the sequence number is 0 and the acknowledgement number is 1, which is over here, and the sequence is over here. It is determined by the website that by adding 1 to the sequence number, I mean like one acknowledgement 1 to the sequence number from client computer, and the SYN flag and the acknowledgement flag are set to the 0. See over here you can see that SYN flag and acknowledgement flag are set to 1, right? It indicates that that segment is a SYN-ACK segment. Okay. And next question, what is a sequence number of TCP segment containing the HTTP post command? So for that, just scroll it up till the end until you find one HTTP. Yeah, this is a HTTP one, right? Ethereal Labs. And over here, what is the sequence number of it? The sequence number is 199. Okay. What is the sequence number of the TCP? Yeah, the sequence number is 199. No. The sequence number. Of the, wait. What's the sequence number was a question asked, right? So it's in the 199 segment, and it contains a HTTP post command, and the sequence number of this segment 199 has a value of 164041, which is mentioned over here, right? So next question, guys. Consider the TCP segment containing this the HTTP post as first segment in the TCP connection. What are the sequence number of the first segments in the TCP segments, including, and what are the, and we have to find the estimated RTT, right? So yeah, and for that, what you have to do is segments 1 to 6, right? First we have to find the segment 1 to 6. Yeah, and for the segments 1 to 6, just take any let's say, for example, over here. Now take anything, for example, it must start with len 565, right? Hold on a second. Yeah, these may let's consider it as a first thing because the sequence is mentioned as a 1, right? So first 6, right? So the first segment is and the send time for it is 0.02. Hold on a minute, this is the first one, and the second thing is over here. Let us see, that's the first sequence, and that's the second, and the third one is this thing, and the fourth one is this thing. Hold on a minute, I'll just explain you guys like what it is and how why we have considered this specific things. Okay, firstly we'll just this is the first thing and this is the second thing, and this is the third thing, and this is the fourth thing, and this is the fifth, and this is the sixth. So here the sequence numbers. So first 5 6 sequence numbers, right? So first 1 2, it's in a particular order, right? So 1 2 3 4 5 6. These are the 6 sequence number segments, and and again we need to consider the acknowledgement numbers. So for that, consider the sixth one as the first one, because it's mentioned over like this is first sequence. So first one and second one, third one, fourth one, fifth one, sixth one. So these are the complete 6 acknowledgements. So after having these things, you need to calculate the estimated RTT time. So for that, you can calculate it by using a formula known as 0.875 into estimated RTT plus 0.125 into sample RTT. So for that, first divide it to like segment, send time, acknowledgement, receive time, RTT. Once you have this table, calculate it with this formula 0.875 into estimated RTT, and so on, so on, so on, so on, so on. You'll get it like 0.0276, and next thing is 0.0285. Add it to this, and you'll get it till the first 6 segments. So in this way you get the estimated round trip time, and after getting the estimated round trip time, we'll see how it is in terms of graph, right? So in the statistics, okay, see for example in the statistics, hold on a second, yeah, in the statistics, if you go toward the TCP, and in that you must go to the round trip time, and now switch the direction. Okay, this is the graph particularly that you get for this particular question. Okay, I mean like for this ethereal trace. Okay, and next question is what is the length of each first 6 segments? So the length of first segment is 565, I guess. So wait a second, length of first thing 5, yeah, we have got this as a first thing, right? And hold on, 1 1 3 4 5 6. Okay, yeah. Now the difference between the second and the first one is 565, and from this to 20.26 there is a same difference of 1460, and from this to this 1460, and from this to this 1460, and till the 6 segments it has a same difference. So the length of first TCP segment is 565, and the rest for the 5 TCP segments is 1460. Okay, and now for this question, what's the minimum amount of available buffer space at the received for the entire trace, and does it the lack of in receiver buffer space ever throttle in the sender? So for that question, we can see that minimum buffer space is 5840. Okay, and it steadily increases from here, like see 17 15 20, and 17 15 20, again it got decrease, again increasing. It has a steady increase, right? It has a until maximum thing of till 62,780. Okay, it increases a maximum receiver buffer size of 62,780 bytes, and the sender is never throttled due to lacking of receiver buffer space because of its constant rise. Okay, and next question, are there any retransmitted signals in the traced files? See, and what did you check in for the trace in order to answer this question? Okay, so for this question, actually there are no transmitted files in this, and we can verify it by checking the sequence numbers of the TCP segment. So for example, let's just say in the statistics you go to time sequence, right? Again switch the direction. Over here it has a constant rise, right? If it's repeated, if it's repeated we get error, right? Like we can then say the signals are segments are retransmitted. So as of now, in this graph of this trace, all sequence number from source to destination are increasing constantly with respect to time. If there is a retransmitted segment, the sequence number of this retransmitted segment would be the would be in the parabola shape. So that was not in this case. Okay. Next question: how much data loss does a receiver typically acknowledge in acknowledgement, and can you identify cases where the receiver is hacking? See, we must for this how much data that has been acknowledged. So okay, for that, first acknowledgement is 566, right? Oh, yeah, yeah, here first acknowledgement is 566. Over here, what's the acknowledgement data? Acknowledgement data is 566, and similarly for the next acknowledgement is 2026. Okay, and again TCP segment, right? Yeah, over here if we just see that TCP segment data. Yeah, now if you see once if the thing if it is transmitted in a sequence number of 566 acknowledgement number, it has a time sequence data of 565 bytes, 566 bytes, and it goes on like constantly increasing, right? Let's say over here it has been 1460, and over here hold on a second, yeah, and over here it has been 1460, and it goes on, and again the data would be completely same, the acknowledgement data for as we increase the acknowledgement sequence number from 566 to 2026 to 3486 to if we keep on increasing 3486 and 4946 and 6406, and again constantly keep on increasing it, what we get is the same acknowledgement data for the rest of the acts. So the difference between the acknowledgement sequence number of two consecutive acknowledgements indicate that the data received by the server between these two acts, and after inspecting the amount of data by each acknowledgement, there are cases like where the receiver is hacking every other segment. See, for example, in the segments like 80, let's just go to the segment 80. Here there is a this hold on. Here the acknowledgement data is like a 2920 bytes, and we 2920 bytes is nothing but 1420 into 2, right? So the data is been doubled or the same. Okay, so here the data is been the same. Okay, see, even for this the data has been same, even for this the data is been there has been some difference. Okay, and you get that difference. The next question is what's the throughput for the TCP connection, and how we can calculate this value. So the throughput for a TCP connection could be calculated by a formula called TCP window size by round trip time. Okay, this is a formula. And the next thing, use this is like use a time sequence graph plotting tool to view the sequence number versus a plot of segments. Okay, time sequence grams, we have done it before, right? So this question is completed, and answer each of 2 questions about the trace that have gathered when you have transferred a file. We did answer the question. So yeah, that's it guys, thank you.